today we're looking at the inverse of a function. Now the inverse of a function, let's say the function is f, is defined as f raised to the power of negative 1. Some might say f to the minus 1. And the inverse is indeed a function, but this function will map the range back onto f. Alright? So in other words, this is just interchanging the x and y elements of the ordered pair. For example, if f of x is 3x plus 1, then the set of ordered pairs would be, for example, when x is minus 1, y is negative 2. When x is 0, y is 1. When x is 1, y is 4. And so, if you were to write down f inverse, then f inverse would be interchange the x and y value to have negative 2, negative 1, 1, 0, 4, 1, and 7, 2. So since f inverse has to be a function itself, then the inverse of a function only exists if the original function is 1 to 1. So the only way that you can get the inverse of a function is if it is a 1-to-1 function. Always remember that. That's going to play key later on. So now you might wonder, how do you find an expression for the inverse of a function? So let's go. The function we were looking at was f of x being 3x plus 1. So to find the inverse, step 1, you're going to call the function f of x y. Alright, so that is y is equal to 3x plus 1. Step 2, you're going to interchange x and y. So where x is, you put y, and where y is, you put x. So now x is 3y plus 1. Step 3, you're going to make y back the subject. Making y back the subject, you're going to have x minus 1 is 3y. And then, to make y the subject, we divide both sides by 3. And so, that y now is f inverse of x. So f inverse of x in this case is x minus 1 over 3. Now remember the mapping diagram? You could construct the mapping diagram for f of x and f inverse of x as displayed on the screen right here. Now notice for f of x, right? We were using the domain between negative 2 and 2 for x. When x is negative 2, the y value is negative 5. When x is 1, the y value is negative 2, and so on. But look at f inverse now. F inverse now, notice that when the domain is negative 5, the y value is negative 2. When the domain is negative 2, the y value is negative 1. When the domain is 1, the y value is 0. What I want you to realize is that the domain of the function of x is equal to the range of the inverse. And the range of f is equal to the domain of the inverse. Alright, just something for us to observe and note down. Alright, so now here are some questions for you to attempt. So pause the video and attempt these questions. Find the inverse of the following functions. G of x is 3x plus 2 and f of x is 4x plus 5 over x plus 2. Pause the video and attempt. Alright, so let's start with the first one. So remember, step 1, you let y equal to the function. So in this case, y is 3x plus 2. Step 2, you interchange x and y. So x is now 3y plus 2. And then you need to make back y the subject. So we divide both sides by 3. And so g inverse of x is x minus 2 over 3. That's very good. Nice. Alright, so for the second one, you let y be f of x, and then you interchange x and y. Now you need to make y the subject. But for this one, step 3 kind of looks challenging, right? How are we going to make y the subject there? No problem. What we're going to do first is cross multiply. So we cross multiply to get x times y plus 2 is 4y plus 5. Then we can expand in the bracket. Xy plus 2x equal 4y plus 5. And then we need y's on both sides so we can get y alone. So now we can have xy minus 4y equal 5 minus 2x to get the y's on one side. Factoring out the y, we have y times x minus 4 is 5 minus 2x. we will divide both sides by x minus 4 to get 5 minus 2x over x minus 4. Now that we get y, replace it now with f inverse. And so therefore, f inverse of x is 5 minus 2x over x minus 4. Wow! Nice. Alright. Now, the next thing we're going to look at is composite function. Now, the composite function f g of x, it just means g of x followed by f of x. That is, you apply g of x first, and then you apply f of x to the result of g of x. In this case, g of x is known as the inner function, and f of x is known as the outer function. Alright, so what you're going to do is you're going to put x into g, then you're going to put g of x into f. That is f g of x. Now you're probably saying, wait a minute, all of that sounds like a lot. So let's see it with examples then. So for example, if f of x is 2x minus 1 and g of x is 3x plus 2, find g f of x. That is, find g of f of x. So your inner function is f of x. So let's do this question together. This is obtained by substituting f into g, your inner function into the outer function. So g f of x is g in bracket of f of x, and so where x is in g, you're going to replace it with f of x. So look, we put this in black. We put f of x in black, so it's 3 times f of x plus 2. F of x, 2x minus 1. So it's 3 times 2x minus 1 plus 2. That then becomes 3 times 2 is 6, so that's 6x minus 3 plus 2, which simplifies to be 6x minus 1. That would be g f of x. Let's try one more. Let's say we were asked to find f g of x. That just means that we're going to substitute the inner function g of x into f. So f g of x is going to be f of x is 2x minus 1. Where x is in f, we're going to replace it with the g of x. So it's going to be 2 times g of x minus 1, and g of x is 3x plus 2. So it's 2 times 3x plus 2 minus 1, and that simplifies to be 6x plus 4 minus 1, which is 6x plus 3. That is f g of x. Now there's an important thing that I want you to observe. Notice that f g of x and g f of x are not the same. They are not the same. Do not ever mistake them to be the same. Alright? They are not the same. f g of x and g f of x are not the same. And finally, the last thing we want to look at in this video is evaluating functions at a point. F of x is 2x plus 5 and g of x is 3x minus 1. Find g of 5 and f of minus 3. Now, to evaluate a function at a point, all you will be doing is substituting the x value inside of the function. So g of x is 3x minus 1. So to find g of 5, all you do is replace the x value with 5. So it's now 3 times 5 minus 1, which is 14. G of 5 is 14. F of x is 2x plus 5. So you're going to replace the x value with negative 3. To say f of negative 3 is 2 times negative 3 plus 5, which is negative 6 plus 5, which simplifies to be negative 1. So f of negative 3 is negative 1. That is f of minus 3. Alright? Nice. Alright. So here are some classwork questions for you to attempt. Find the h of 5 and k of 4. Pause the video and attempt. Alright. So first thing, h of x is 4x minus 3 over 2x plus 1. So to find h of 5, we replace the x value with 5. So it's 4 times 5 minus 3 over 2 times 5 plus 1. But then 4 times 5 is 20. 20 minus 3 is 17 over 10 plus 1 is 11. So h of 5 is 17 over 11. Part B, k of x is the square root of x minus 1 all square minus 5. So replace x with 4. So k of 4 is now the square root of 4 times 1. 4 minus 1 all square minus 5. That's 3 square, which is 9, minus 5, which is 4. And then we square root that to get 2. So k of 4 is 2. Nice. Alright. Now, we already looked at composite functions. So here's another question for you to try. Find fg of 2. Yes, find fg of 2. Alright, so to find fg of 2, there are two ways you can do it. First way is to put the x value in the inner function. So we substitute 2 into g. So g of 2 would be 3 times 2 minus 1, which is 5. And then we need to find fg of 2. Since g of 2 is 5, replace g of 2 with 5. So now we need to find f of 5. 2 times 5 plus 5 is then 15. So fg of 2 works out to be 15. That's one way that you can do it. Or you can do it this way. You can find the composite function fg of x. So we find fg of x by putting g of x into f. And remember, we already got it to be 6x plus 3. And then now, we need to just find fg of 2. So where x is, you can just replace it with 2 in the composite function. So it becomes 6 times 2 plus 3, which is still 15. And so fg of 2 is still 15. Alright? So here's one more for you to try. Find gf of minus 1, and I want you to do it both ways. So pause the video and attempt. Do it both ways. Alright, doing it method 1, we substitute the inner value of negative 1 into the function. And we substitute it into the function. What we get is 2 times minus 1 plus 5, which is 3. And then we substitute that value of 3 now into g. So g of 3 is then 3 times 3 minus 1, which is 8. F of minus 1 is 8. Alright. Now, the second way that we could do it, method 2. So first thing is we need to find the composite function fg of x. So replace x with g of x. So it becomes 3 times f of x, which was 2x plus 5 minus 1. That simplifies to be 6x plus 14. That's gf of x. We can then replace the x value now with negative 1. 6 times negative 1 plus 14, that works out to be 8. And so gf of minus 1 is still 8. That's how we evaluate composite functions at a point. Nice. So now, of course, we have to do a wrap-up classwork set of questions which are like exam style questions. This is how it's going to be on the exam. So pause the video and attempt these questions. Alright, so as you pause, let's go through them now. The first one is to find g of 6. So g of x, remember, is the square root of x plus 3. So replace the x value with 6. And we're going to get the square root of 6 plus 3, which is the square root of 9, which is 3. So g of 6 is 3. Now we need to find fg of 6. Now, given that we just find g of 6 to be 3, we put g of 6 in red there, that is 3. So we really need to find f of 3. Now, f of 3 is going to be 2 times, replace x with 3 in f of x. 2 times 3 minus 7 over 3 plus 1, which is 6 minus 7 over 4, which is negative quarter. So fg of 6 is negative a quarter. Nice. Alright. The next part says find f inverse of negative 1 and g inverse of negative 1. So we need to find g inverse. So, alright, let's start with finding g inverse first, since that one looks a little bit simpler, right? So to find g inverse, first thing we need to do is call the function g of x y. So y is the square root of x plus 3. Then we interchange x and y. So x is now the square root of y plus 3. We need to make back y the subjects, so what we're going to do is square both sides. By squaring both sides, the square get rid of the square root. So x squared is y plus 3. Then we subtract 3 from both sides to get y is x squared minus 3. Wow! In this case, we say g inverse of x is x squared minus 3. Now that we get g inverse of x, we can plug in x as negative 1. To find g inverse of negative 1 is now negative 1 squared minus 3. And that works out to be 1 minus 3, which works out to be negative 2. And the g inverse of minus 1 is negative 2.